Welcome to this explainer. When we talk about the electric vehicle revolution, our minds almost always jump straight to the flashy car manufacturers, right? But what about the infrastructure? What about the absolute powerhouse companies actually building the backbone of the fast-charging network? Well, today we're focusing on an under-the-radar Italian manufacturer called Alpitronic. And this is such a fascinating story because they have quietly but almost completely dominated the European fast-charging landscape.
Here is the roadmap for today. First, we'll track the incredible rise of Alpitronic. Second, we're looking at their mastery of the Hypercharger. Third, we step into the Megawatt era. And finally, we'll see a real-world revolution on the Autobahn.
All right, let's jump right into Section 1, the rise of Alpitronic. From snow cannons to a billion-euro powerhouse? Seriously, how does a company make a leap like that?
This timeline is wild, guys. Alpitronic was founded in 2009 in Bolzano, Italy. They started out as a relatively small power electronics startup in a local techno innovation park, just trying to find their footing. Fast forward to 2016, and what were they doing? Manufacturing control systems for snow cannons. Yeah, you heard that right, snow cannons for ski resorts. But then they executed what has to be one of the most brilliant corporate pivots ever. In 2017, they start developing DC fast charging stations, and by 2018, they roll out their very first 50-kilowatt version. Now jump to 2025, and this former snow cannon electronics company is bringing in around €1 billion in revenue, with a massive team of 1,100 employees.
Now, the sheer scale of their manufacturing explosion is staggering. In 2018, the exact same year they launched their first fast charger, they manufactured just 80 units. The very next year, 2019, that number jumped to 900 units. By 2023, they were pumping out 20,000 fast chargers a year. This isn't just regular growth. This is explosive, exponential scaling to meet a market that was absolutely starved for reliable infrastructure.
And all that exponential scaling brings us to this mind-blowing number, 135,000. By 2025, there are 135,000 Alpitronic charge points operating out in the wild. To put that into perspective for you, this gives them a massive 30% market share across the entire European continent. And honestly, in some specific regional markets, their silicon carbide-based charging stations account for well over 50% of the market. They are quite literally the backbone of European fast charging.
Which brings us to Section 2, mastering the Hypercharger, and the sheer engineering magic behind their HYC400, which really cemented their total dominance.
So the secret sauce here is dynamic load management. Think about it. When you have a massive, high-powered charger, say a 400-kilowatt unit, and two cars plug in simultaneously, how do you divide up that juice? A lot of older systems would just lazily split it right down the middle, regardless of what the cars actually needed, which completely wastes grid capacity. Well, Alpitronic engineered a hyper-flexible system that operates with a granularity of exactly 50 kilowatts.
Breaking down exactly what that 50-kilowatt granularity means in the real world shows why it's such a game-changer. Let's say you have an Alpitronic HYC400 station. If two vehicles pull up and both can take 200 kilowatts, the station splits it evenly, 200 and 200. This perfectly lines up with massive infrastructure projects like the Deutschlandnetz in Germany, which legally requires 200 kilowatts per plug when two cars are charging. But what if one car is a cutting-edge, ultra-fast charging sports car demanding 300 kilowatts, and the other is just a standard EV nearing a full battery only needing 50 kilowatts? The Alpitronic system dynamically adjusts. It routes 300 to the sports car and 100 to the standard EV. Boom! The 50-kilowatt demand is easily met, and the sports car gets the absolute maximum power it can handle. The power is fluidly routed exactly where it's needed, meaning zero wasted grid power.
And get this, it does all of that with an incredible 97.5% efficiency. Their second-generation silicon carbide modules are absolute marvels of power electronics. They've practically eliminated energy loss during the conversion process. And to top it off, the newest generation of the HYC400 has knocked its standby power consumption down to a mere 43 watts. It's an incredibly powerful machine, yet highly efficient.
But passenger cars? That's really just phase one. If we truly want to decarbonize the global supply chain, we have to face the final boss of EV adoption, commercial heavy-duty trucking. Welcome to Section 3. Enter the Megawatt era. Because current standards just don't have the muscle to charge a massive 40-ton truck fast enough. You need the Megawatt Charging System, or MCS.
This is a brand new standard built specifically for commercial heavy-duty vehicles, and it's capable of pushing power well over 1,000 kilowatts. So to meet this new era head-on, Alpitronic introduced a completely new system in 2025, the HYC-1000.
The evolution of their architecture here is brilliant. Normally, a traditional high-power charger crams all those heavy, heat-generating power modules right inside the bulky station sitting next to your car. But when you're dealing with a literal megawatt of power, no way. The footprint is just way too massive for that. So Alpitronic completely decentralized the whole thing. With the HYC-1000, they created a centralized power cabinet that you can hide away off to the side, which then feeds power to up to 8 separate, super sleek vehicle dispensers. It is a drastically smarter use of physical space, especially at crowded truck stops.
And the specs on this power cabinet are frankly, well, they're intimidating. A single cabinet delivers a total of 1,000 kilowatts of power. It operates across a massive 150 to 1,000 volt range. It upgrades that dynamic load management we talked about earlier to an ultra-precise 62.5 kilowatt granularity across those 8 different dispensers. And to physically push all that energy into a truck without melting the hardware, the MCS dispensers utilize actively oil-cooled cables capable of supporting up to 1,500 amps. It is an absolute beast of a system.
Okay, so the theoretical engineering sounds amazing, but what does it actually look like in the real world? Let's jump into Section 4, Revolution on the Autobahn. We're looking at the 1 megawatt reality in Bolzano, focusing on a massive launch in May 2025 on the A22 Brenner Autobahn.
To really grasp why this May 2025 launch is such a massive deal, we have to look at the state of Italy's charging infrastructure in late 2024. Out of over 64,000 charge points, 94% were standard power, meaning under 150 kilowatts. Only 6% were high-capacity power. So when the Brenner Autobahn inaugurated an actual 1,000 kilowatt MCS station at the Fermion parking area in Bolzano, it wasn't just a minor upgrade, it was a monumental leap forward for European infrastructure.
Alpitronic CEO Philip Sinonner absolutely hit the nail on the head at the launch when he said, "The future of transport is electric, and that requires a powerful and reliable charging infrastructure." It's an incredibly ambitious vision, and it's one that actively turns the A22, which is a major commercial artery between Northern and Southern Europe, into a true digital green corridor.
Let's walk through how this actually plays out for a truck driver, because this is where it all clicks together. One of the biggest arguments against electric trucking has always been the downtime required for charging. But look at how this MCS system completely solves it. Under European law, a driver can operate a heavy-duty truck for a maximum of 4.5 hours. After that, they are legally mandated to take a 45-minute rest break. Now, with the HYC-1000, during that exact 45-minute break, the driver plugs in. It takes just 30 minutes to fully charge a massive 600 kilowatt-hour battery at 1 megawatt. They instantly gain 500 kilometers of range, finish their coffee, and get right back on the road. The charging time perfectly overlaps with the legal break. There is zero extra logistical downtime. None.
And the best part? The Brenner Autobahn site isn't just some one-off pilot project. It is a fully future-proof hub. Right now, 3 charge points are active off that single cabinet, including 1 MCS and 2 CCS2 points. But they've already installed a massive 2,000 kVA transformer. That means the site is completely prepped for a second 1 megawatt system to double capacity whenever they need to. On top of that, they're partnering with AVL Italia to integrate on-site battery storage systems. This lets them use peak shaving, basically storing energy when grid demand is super low, and then using those batteries to help push that intense 1 megawatt of power into the trucks when the grid is stressed out. They're literally stabilizing the local grid while guaranteeing maximum charging speeds. Talk about future-proofing.
Which leaves us with this final thought. We've gone from a small startup making parts for snow cannons to the absolute masters of the Hypercharger, and now all the way to decentralized megawatt systems that literally eliminate logistical downtime for heavy freight. With charging times now perfectly matching mandatory driver breaks, are the last major roadblocks to electric heavy transport finally out of the way? It is a fascinating question, and thanks to the quiet giants of infrastructure like Alpitronic, the answer is looking more like a resounding yes every single day. Thanks for joining me on this explainer, and keep your eyes on the grid.